All right, so I'm going to do a midterm review here for discrete math. So it's a terrible marker. This review is going to be very, this is also pretty bad. Well, no, it's not bad. This review is going to be pretty informal, so like you'll notice there's going to be a lot of sort of little bloopers like that. There's a midterm review for CSCI 2110 and Math 2080. There we go. All right, so usually the way that I'll do midterm reviews is I usually like to do it in front of a class, but since it's reading week and just the timing didn't work out, I'm doing it sort of pre-recorded here. So let's, usually the way that I'll do it though is I ask what topics we covered in the course. So the first topic that we really started with here was propositional logic. So what do we mean by propositional logic? Probably remember seeing like sort of lowercase p, q, maybe r, where these were like truth values, right? They were propositions. And we could like assign these like meanings. So we could say like P meant, I don't know, something, Q meant something. So we call these propositions. And there's different operations we could perform with propositions. So one of them was the AND operator. One of them was the OR operator. We had the NOT, which looked like this. We had the XOR, which looked like this. We had implication or conditional, and we had biconditional. Looked like that. So we had a few different things here, and yeah. So sort of from this propositional logic, we started doing truth tables, right? So we did truth tables. Now this might be something that could possibly show up on the midterm, where you're given an expression. Let's say, for example, say P or Q implies P XOR not Q. I don't know, just some random expression, and you're asked to write out the truth table for it. So usually the way that you'll do this is you'll write out P and Q, and you'll write them as like, so I'll write this up and then I'll explain how I'm doing it. So usually what you'll do is you'll, from the rightmost variable you have, you'll alternate 1, 0, 1, 0. And then as we move left, we'll do 1, 1, 0, 0, and so on. If we had 3 variables, this might be useful to know. If we had 3 variables, it would look like, for example, P might be 1, 1, 1, 1, 0, 0, 0, 0, and then Q would be 1, 1, 0, 0, 1, 1, 0, 0. So we have 4 1s, 4 zeros, then it's 2 1s, 2 zeros, 2 1s, 2 zeros. And then the last one is always just alternating. So hopefully you can sort of see the pattern there of how we come up with these. This gives you every possible combination of 1 and 0 for P and Q. Okay, so once you have that, usually what I try to do is divide up the equation that we have into some chunks. So I have this chunk here, which is the P or Q, and I have this chunk here, which is the P XOR not Q. So I'll write out P or Q first. And what I'm doing is I'm literally applying P or Q. So I'm going 1 or 1 is 1. 1 or 0 is 1. 0 or 1 is 1. 0 or 0 is 0. Okay, and then from here, we'll write out the next expression here, which was the P XOR not Q. So we have P XOR 0, 1 XOR 0, sorry, because not Q is 0. So 1 XOR 0 is 1. 1 XOR 1 is 0. 0 XOR 0 is 0. 0 XOR 1 is 1. And then from here, we're just going to do that conditional. So we're going to do apply the conditional. And you can give these things names if you want. You could say like this might be, let's say, A, and this might be B. Then we get A implies B, and that's all we have to do. We don't care about anything before. All we care about is A, B, and then A implies B. So does 1 imply 1? Yes, it does. Does 1 imply 0? No, it doesn't. Does 1 imply 0? No, it doesn't. Does 0 imply 1? Yes, it does. So this whole expression here is the same thing, and I can write this sort of like this. P or Q implies P XOR not Q. This is the same thing, so we use a three-lined equal sign to mean is the same thing. This is the same thing as P implies Q. Is that? No, it's not, sorry. P biconditional Q. So how did I get that? Well, this part here, this 1, 0, 0, 1, that's literally the truth table for P biconditional Q. So we could simplify this logic from this big expression all the way down to just P biconditional Q, which, in case you weren't aware, P biconditional Q is the same thing as the opposite of P XOR Q. So yeah, hopefully that makes sense. That's a good sort of point here for me to see if I can find an eraser and wipe off this, let's see, there's an eraser. All right, so we'll wipe this off and we'll move on to the next sort of topic here, which I think was predicate logic. Once you have your handle on propositional logic, we move on to predicate. So what's a predicate? Well, what's a predicate? So predicate logic, predicates are like functions. They take in variables. So usually you use capital letters to denote this predicate. So we have P of X, Q of X, maybe R of X, something like that. Okay, so predicates are basically like, you can think of the whole predicate here, this whole function, as being very similar to a proposition, in that like the same logic here applies. So like if you have P of X or Q of X, you know, it's the same idea. It's just this is one thing and this is another thing, right? So yeah, that's basically what it is. You're plugging in a variable. So usually this allows you to make a function that often you can plug different variables in, and maybe you might do that in the question. But you don't really have to think that far into it. You can just think of it as like a proposition. So yeah, so the idea here is like maybe, let's say for example, P is, or let's say, usually write your variables first. X means a person, and let's say P of X means X owns a dog, right? So then if P of, for example, if you put me in there, P of Ben, you would get true. That's true. That's 1, however you want to write it. Whereas somebody who doesn't own a dog, say that like, I don't know, John doesn't own a dog, that P of John is 0, because John does not own a dog. And you can do sort of logic with this, right? So you can, you know, pick different variables for X. Maybe you have multiple predicates or these functions, multiple functions going on. But that's the idea here. So I'm gonna wipe some of this off, and we'll talk quickly here next about I do want to talk a little bit about equivalences. So there's usually, like, you might have to show that two propositions or two predicate statements are equivalent here. And I want to show you just some like rough idea of how that works. So say you have P and Q, and maybe we'll say R are predicates. We're going to write out some equivalences. So if you have P, well, maybe a good first one is that P and true is the same thing as P, right? Because, you know, one's always true. So really the only thing that this matters is P, that this is based on is P. And you can write this as one, or you can write this as like true. Really doesn't matter. So it's a tautology, right? Tautology means true. Tautology is true, and the opposite of that is a contradiction, which is false. So, okay, so we have this expression. What about, can we do something with an or? P or false is P. Why is that? Because false is not going to change this expression. P is the only thing that matters. Now you can sort of do the opposite of each of these. So there's P and false is always false, and P or true is always true. And I'll let you sort of logic through that. We also have, it's true that P or Q is the same thing as Q or P. This one's called commutativity. And we can do commutativity with ors or ands. P and Q is Q and P. So we have that. We also have associative. So we can say that P and Q and R is the same thing as P and Q and R. And we have the same thing for or. Cool. All right. So we got that. So there's our equivalences. And there's a few more actually, maybe I can go into. We can do some that have to do with like, so P biconditional Q, I said that one earlier, is the same thing as P, well, I should write it probably as not P XOR Q. And you can sort of logic that out however you want. We also have P implies Q is the same thing as P or not Q. And again, logic it out. You can do that using truth tables if you want to verify it. That's a good exercise, actually. I think there's a couple more that I want to talk about, which are the De Morgan laws. De Morgan laws are, in this case, we have, it's negating ands and ors. So if we do negation of P or Q, we get not P and not Q. So you bring how do you say it? Bring the negation in and you expand out the nots. And we can do a similar thing here for, sorry, you bring the negation in and you flip the or to an and. We can do a similar thing here for starting with and. We get not P or not Q. There's a few more laws and you should know them, but I think that gives you like a good starting point on the equivalence laws. And if you're solving for something using equivalences, you're just sort of doing algebra, right, on this. You're like almost like solving an equation. It's the same idea. You're just doing it for equivalences. So hopefully that makes sense. Yeah. I think that's everything I want to talk about with equivalences. So maybe we can move on to talking about quantifiers. So what's a quantifier? Well, quantifier is like for all or there exists. So it's either for all, which we call the universal quantifier, or it's there exists. And really I should be putting these like in quotes kind of. There exists is the existential quantifier. Now we have symbols for each of these. So for all, we use, maybe I'll put it over here. For all, we use an upside down A. And there exists, we use a backwards E. Why do we use them? Mathematicians are weird. No good answer. So usually you're going to use this with like predicate logic. So you might say something like, for all x, p of x, and q of x. And from here, you sort of try breaking things down. So, you know, a lot of times you'll be asked to like manipulate different laws. Always try and see like, if you're doing something like this where it's like, it wants you to start at something and like end at something else, make sure that like each line that you write, so for example, line 2 needs to follow from line 1. So if you know line 1 is true, you need to make sure that line 2 follows from that. And then if you do line 3, you need to make sure that line 3 follows from line 1 or from line 2, right? So you can use either of them because now these are 2 true statements. So you just keep building and building and adding new, more and more true statements until eventually you reach the end. So that's the idea with quantifiers. You have for all, you have there exists. There's also like a relation between them. So if you have something that's like for all x, let's say p of x is true, you can negate that. And so the negation of this is going to be, if you negate this whole statement, it's there exists an x, not p of x. And you can sort of like logic this out, right? So here we have, so it says, it's not true that every x meets this condition, which is the same thing as saying there is some x which does not meet this condition. Because if it's not true that everyone meets that condition, there's at least one person who doesn't, right? Or one x that doesn't. And you can do the same thing just in reverse here. So not there exists an x such that p of x, this is the same thing as for all x, not p of x. So, and again, we'll read this out. So it's not true that there's some x where p of x is satisfied. So there's no such thing. There's no x, which means for every x, p of x is not true, right? Because if that was false, then you'd have, there would exist some one person, right? So it's the kind of idea here is that you're like, and it's kind of like a, you know, almost feels like De Morgan line that you have to flip the thing back and forth. But yeah, hopefully that makes sense. I think that's it up to quantifiers. I think from there I'm going to take a bit of a break. So hopefully, you know, this makes some sense. I'll be planning, if you're watching this like sort of as I post it, my plan is to release a few more videos, so I'll probably just do them in sections, maybe like 3 or 4 different videos, just to give you like a bit of a, have it a bit broken up. Yeah, so that's the idea. Hopefully that helped. So again, for this section we covered propositions. I think technically, like in between there, we covered equivalences. And then 3 was, we covered predicates. And 4, we covered quantifiers. And so I believe this was from week 1. And this was from week 2. So next time we'll be starting talking about proofs, stuff from week 3, doing some really basic proofs, and then we'll move on from there to more interesting things. So hopefully that makes sense. This is just some basic logic. If you have any questions, you can always send me an email. I'll write up my email here so that you have it, but it's also posted on my website, on my homepage, which I think you have access to if you found this video. Oh, sorry, I'm writing my email. At OntarioTechU.ca. So you can send me an email. Even if you're watching this later and you're not like a current student of mine, I don't mind if you send me an email. It's not a problem at all. So just send me an email. So yeah, good luck studying, and if you have any questions, yeah, reach out.